Welcome to the new tutorial. Here in this tutorial, we will build a real-time color detection desktop app. This is a Seat Studio ESP32 camera module. It connects to Wi-Fi and displays an IP address in the serial monitor of the Arduino IDE. This is a demonstration video. Here it displays a live stream video and detect the color on the content, like blue, white. Let's dive on the program. It has buttons and a black picture box that display the live stream video. Now in the programming section, the app uses a built-in HTTP client to open a long-lived HTTP connection to the ESP32. The response is a continuous stream of JPEG images. The app reads the stream byte by byte, searching for the JPEG start marker 0xFF0xD8 and end marker 0xFF0xD9 to slice out each individual image frame. In an MJPG stream, images are sent one after another. The read stream method scans the incoming data. When 0xFF0xD8 is found, start capturing bytes into a memory buffer. When 0xFF0xD9 is found, the full image is ready. Call process frame to analyze it, reset, clear the buffer, and look for the next frame. This lightweight approach requires no third-party libraries and works directly with raw data. Once a frame is decoded, the detect color method analyzes the pixels using these 5 steps. Focus on the center. The algorithm only looks at the middle 50% of the image. This ignores background noise at the edges and stays locked on your subject. Smart sampling. To keep the app fast, we check every third pixel instead of every single one. This provides high accuracy without lagging the CPU. Convert RGB to HSV. RGB, red, green, blue, is hard for computers to name. We convert pixels to HSV hue, the actual color angle, 0 to 360 degrees. Saturation, how vivid the color is. Value, how bright the color is. Classify each pixel. Using HSV, we sort pixels into categories, red, green, blue, black, or white, based on their specific ranges. Pick the winner. The category with the most pixels wins. If no color fills at least 5% of the area, it returns no clear color. Now let's go to Arduino. Alright, here you have to download the ESP32 library first and adjust the board. Here the serial monitors show the message. Not connected. If the camera module is connected to a serial port, it will display the IP address in the serial monitor like this. Here it displays the IP address of the camera, and now we connect our Visual CSharp application with camera via IP address. Now let's run the application. When the application is open, it will not connect automatically. We have to click Connect button. If your IP address is different, you can also change here. On clicking Connect button, it displays the video and detect the color as well. As the source code download link is in the description box, feel free to use. Thanks for watching.